Welcome back to Blueprint to Reality. Today, we're exploring one of the most critical forces in structural engineering, shear force. Whether you're building a simple house or a towering bridge, understanding shear force is essential for ensuring the stability of any structure. But what exactly is it, and why is it so important? Let's break it down. What is shear force? In simple terms, shear force refers to the internal force that acts along a structure's surface, causing two adjacent parts of the material to slide past each other. Imagine holding a deck of cards and pushing the top half sideways. The cards move relative to each other. That's the same idea as shear force in a structure. When external loads like wind, weight, or even earthquakes push on a building, shear forces occur inside the materials. How does shear force occur? Shear force is a direct result of loads acting on a structure. For example, when a beam is subjected to loads from above, part of the beam tries to move vertically, while the other part resists this movement. This creates shear forces within the beam, which can lead to cracks or even structural failure if not properly accounted for. Shear force diagrams help engineers visualize how these forces act along the length of a beam or structure. The higher the force in a particular area, the greater the risk of structural damage if not designed carefully. Why does shear force matter? Shear force matters because it directly affects a structure's ability to resist failure. If shear forces become too great for the materials to handle, the structure may experience 1. Shear cracking. This happens when materials break along a plane where the shear force exceeds the strength of the material. 2. Buckling. Shear forces can also cause structural elements like beams and columns to buckle or bend, leading to potential collapse. 3. Structural instability. Even small shear forces, if left unchecked, can weaken a structure over time, making it unsafe for continued use. To combat these risks, engineers use reinforcements like steel bars in concrete or diagonal bracing in tall buildings, designed specifically to resist shear forces. Shear force in everyday structures. You encounter shear forces every day, often without realizing it. Take a simple bridge, for example. As vehicles move across, the bridge experiences shear forces along its supports. In skyscrapers, wind creates lateral forces that introduce shear into the beams and columns. Engineers carefully calculate and design around these forces to ensure the structure can safely resist them. So, why does shear force matter? Because it's a silent but powerful force that can dictate whether a structure remains stable or fails catastrophically. Thanks for joining us today on Blueprint to Reality. Be sure to subscribe for more insights into the fascinating world of structural engineering.
See you next time.